All right, let's dive into something that might sound a bit dry at first glance. Software design principles.
Oh, yeah. You know the stuff that makes your eyes glaze over.
But trust me on this one, we're going deep on solid principles.
Not the kind that keeps your beer cold, though.
Exactly. This is about the principles that keep your code from turning into, well,
Yeah, a big mess. Let's be real. This isn't just for us code monkeys,
Oh,
though.
no, not at all.
Whether you are building software in a house or even planning your next trip,
Ooh, a trip?
these principles help you create something that's not just functional, but adaptable, elegant and resilient.
So basically setting us up for success in any field.
You got it.
Okay, so first things first, what does SOLID even stand for?
All right, so SOLID, it's an acronym for 5 key principles: single responsibility, open-closed, Liskov, substitution, interface, segregation, and dependency inversion.
Wow, that's a mouthful.
It is. It's like the Avengers of software design principles. And you know who was a big fan of these?
Ew.
Uncle Bob himself, Robert C. Martin, the godfather of clean code.
Ah, a legend.
Yeah, and for good reason, they're like the foundational building blocks of good software design.
Okay, so let's break these down one by one, starting with single responsibility. What's the single responsibility this principle is so concerned about?
Okay, so think of it this way. Each module or class in your code should have one and only one reason to change.
Keep it simple, stupid, right?
Exactly. It's like a good chef's knife. It's amazing for slicing and dicing.
But you wouldn't use it to hammer in a nail.
You got it. There you go. So each piece of code should have one job and do it well.
So how does that play out in actual code?
Okay, let's imagine you're building an online store.
Okay, I like shopping.
Who doesn't? You might have one class that's responsible for handling user authentication,
That makes sense.
another for processing payments, and another one for managing the shopping cart.
So each class has its own little job to do.
Precisely. Each of these classes has a single, well-defined responsibility.
And by keeping things separated like this, you avoid creating those massive classes that are just a nightmare to deal with.
Oh, tell me about it. It's like trying to find a needle in a haystack when you have these giant classes that try to do everything.
Right. So when you need to make a change, you know exactly where to look.
Exactly. You don't have to wade through a tangled mess of unrelated code.
Okay, that's single responsibility.
Yep.
What about open-closed?
Yes. It sounds a bit contradictory, doesn't it?
Yeah, a little bit.
Open for extension, but closed for modification.
Explain it to me like I'm 5.
Okay, imagine you're building a house and you have a really well-designed electrical system.
I hope so.
You want to add a new appliance, right?
Yeah, like a fancy new coffee maker.
Exactly, no problem. Just plug it into an existing outlet. You don't have to rewire the whole house every time.
So you're future-proofing your code.
Exactly.
Yeah.
You are designing it so it can easily adapt to new requirements without breaking everything.
I like the sound of that. Less work for us.
Always a plus, right?
Oh,
A
wow.
classic example is a payment processing system.
Okay.
You
Yeah.
need to add a new payment method like accepting Bitcoin.
Gotta get on that crypto train.
You shouldn't have to modify the existing code for credit cards or bank transfers. You just add a new module that plugs into the existing system.
Seamless integration. So open-closed is all about creating a more modular and flexible system that can evolve over time.
Nailed it.
Hmm.
Now let's move on to the Liskov substitution principle.
Ooh, getting technical now.
A little bit, but it's a crucial one for keeping your code healthy. Think of it like this. You have a recipe for chocolate chip cookies.
I'm listening.
You can swap out milk chocolate chips for dark chocolate, and it'll still be a delicious cookie.
Okay. Yeah, still good.
But if you swap out the flour for, say, sawdust, it's not going to turn out so well.
Not so much.
Right. So subclasses should be able to stand in for their parent classes without messing up the core functionality.
Got it. So in our online store example, if you have a class for products and then subclasses for books, electronics, and clothing, you should be able to treat any of those subclasses as a product without running into problems.
Exactly, you're getting it. The Liskov substitution principle makes sure your code is robust and that you're not introducing weird bugs by using subclasses incorrectly.
So it helps you build a system where all the pieces fit together nicely, even as you add new types of objects.
Precisely. It's all about harmony in your code.
Love it. All right, so we've tackled single responsibility, open-closed, and Liskov substitution. What's next on our solid adventure?
Okay, let's talk about interfaces, specifically the interface segregation principle.
Ooh, interfaces now we're getting fancy.
This one's all about keeping interfaces streamlined and focused, tailored to the client's needs.
So not like my kitchen drawer where I shove everything in.
Yeah, not exactly. Although
Well,
we've all been there. In software, an interface is like a contract that defines how different parts of the system will talk to each other.
okay, so it lays out the methods and properties a class should have.
Exactly. It's like a blueprint.
So is the interface segregation principle saying that we shouldn't force classes to implement methods they don't actually use?
You got it. Imagine you're at a restaurant with this massive menu that tries to cater to every single dietary need.
Oh, God, yeah. It's overwhelming.
It's too much, right? It's much better to have separate focused menus, vegan, gluten-free, whatever. So each customer only sees what's relevant to them.
So it's like decluttering your code, making sure each class only has the tools it needs.
Exactly. You're avoiding those fat interfaces that bloat your code and make it a pain to maintain.
Like trying to find something in a messy closet.
Right. Think about it. If you have a class for worker and another for robot, it wouldn't make sense for both to have a sleep method.
Robots don't sleep, they just power down.
Exactly. They don't need a sleep function, so why have it?
Makes sense. I'm starting to see how these principles all work together.
Yeah, they're like puzzle pieces.
Single responsibility keeps classes focused, and interface segregation makes sure they're only talking to the parts of the system they need.
Exactly. It's all about creating a system that's modular, adaptable, and easy to understand.
All right, bring on the final principle, dependency inversion.
This is where things get a little more mind-bendy.
Hit me with it, I'm ready.
Dependency inversion is all about how different modules in your code rely on each other. The idea is that high-level modules shouldn't depend on low-level modules.
Okay. That sounds a bit abstract.
It is. Let me give you an example. Imagine you're building a system that sends notifications.
Like email alerts or something.
Exactly. You could write your code so that it's tightly coupled to a specific email provider like Gmail.
Okay, but what happens when you want to switch providers?
You'd have to go back and rewrite a bunch of code, which is a pain.
Yeah, I'd rather avoid that.
That's where dependency inversion comes in. You would design your system to depend on an abstract interface, like a notification sender.
So you're not tied to one specific provider.
Exactly. Then you could have different implementations for email, SMS, or any other notification method you might need in the future.
So you're creating a layer of abstraction that lets you swap things out easily.
Precisely. It's like building with Legos.
Yeah.
The pieces connect in standardized ways so you can create whatever you want.
You're not limited to using specific bricks together.
Exactly. You have the freedom to build whatever you can imagine.
Okay, I'm seeing a pattern here. All these solid principles are about creating systems that are modular, flexible, and adaptable.
You got it. It's like you're anticipating future changes and building them into your design.
It's like having a crystal ball for your code.
And that's what makes solid principles so powerful. They're not just about writing code. They're about building systems that can evolve and grow.
So they can stand the test of time.
Exactly. Now, we've talked a lot about code, but what's really interesting is how these solid principles apply outside of the software world.
Oh yeah, tell me more.
They offer valuable insights for approaching any complex task, They force you to think about how to create things that are well-organized, adaptable, and resilient to change.
So it's like solid is a philosophy for problem solving, not just coding.
Precisely.
Yeah.
Take the single responsibility principle, for example. In life, just like in software, taking on too much can lead to burnout.
Yeah, trying to be everything to everyone, you end up doing nothing well.
It's like that saying, jack of all trades, master of none.
So focus is key.
Absolutely. And then there's the open-close principle. In life, we're constantly faced with new challenges and opportunities. We want to be open to these new things, but not at the cost of our core values or identity.
So it's about having a strong foundation that can accommodate growth.
Exactly. Like a tree. It grows and branches out, but it stays rooted in the ground.
Yeah, that's a great analogy.
Yeah.
So how about the Liskov substitution principle? How does that apply to real life?
Well, think about a well-functioning team. You've got individuals with their specialized skills.
Right, everyone has their strengths.
But you should be able to move people around and have them cover for each other without the whole operation falling apart.
So like cross-training or having people who understand the big picture and can step into different roles.
Exactly. The Liskov substitution principle is all about making sure the parts of your system, or your team in this case, are interchangeable without sacrificing, functionality.
So it's about having that flexibility.
Right. Having a team that can adapt.
Okay, that makes sense. What about interface segregation? Can we apply that to real life too?
Oh, absolutely. Think about communication.
Okay.
We don't overload people with information they don't need.
Right. No
Yeah.
one likes information overload.
We tailor our message to the audience and the situation. It's about respecting people's time and, their mental bandwidth.
Don't bury people in details they don't need.
Exactly. Just give them what they need to know.
So be mindful of the essential information.
Exactly. And finally, we have dependency inversion.
The grand finale.
This one's about understanding the power of abstraction and avoiding unnecessary reliance on specific tools or processes.
Okay, I'm curious. Give me a real-world example.
Okay, let's say you're planning a trip and you rely entirely on a travel agent to book everything for you.
Okay, I see where you're going with this.
What happens if that agent goes out of business or you just have a terrible experience?
You're stuck.
Exactly. But if you book things directly with airlines and hotels, you have more control and flexibility.
More free.
Right. It's about understanding where our dependencies lie and trying to minimize them where possible.
So we're not so vulnerable to disruptions.
You got it.
This has been amazing.
Yeah.
We often get caught up in the details of our work and forget to think about these underlying design principles that can make everything run smoother. Not just in code, but in life, too.
It's true. We can get tunnel vision.
And it's like, solid is a philosophy for problem solving, not just a set of coding rules.
Exactly. It's a way of thinking.
So we've uncovered this secret code for building better systems, whether they're made of software people or ideas.
It's all about seeing those deeper patterns.
And maybe we'll start noticing these principles in all sorts of unexpected places now.
I hope so. It's a new way of looking at the world.
Well, this has been an incredible deep dive into solid principles. Thank you so much for breaking it all down for us.
It's been my pleasure. Always happy to geek out about software design.
And for our listeners out there, remember, don't get so caught up in the latest trends and technologies that you forget the foundations that have stood the test of time. Sometimes the best innovations come from remembering and respecting the good old principles that still work.
Couldn't agree more.
Thanks for tuning in to The Deep Dive. We'll catch you next time.